My name is Rita Zagoni, and I work with Africa's Voices Foundation as a researcher and, well, all-around tech person, I would say. My background is in social science. I studied sociology and then veered into data science and technology. Africa's Voices is a research organization. We're based in Cambridge, UK, and partly in Nairobi. So what I'm going to talk about is how we use machine learning and especially text classification in our research projects. A bit of background and context of how and why we work. So we spun out from a research project at the University of Cambridge, and we're working with a range of development organizations, mostly in East Africa, such as Oxfam, with project with Jul20 Story in Kenya, Liberty in South Africa, and one of our biggest projects is with UNICEF Somalia, and this is going to be the base of my presentation, the case study, the work that we're doing with UNICEF Somalia. So a few words on our general approach. What we're trying to do is to engage citizens in discussions through, in spaces that they already use and value, such as radio shows, engagement around Facebook pages, Twitter hashtags, and we use digital methods to hear about their opinions. So we either mine the Facebook pages and Twitter, or we use WhatsApp, and in many cases we use SMS to gather data and opinions from citizens. We analyze these messages and in the end deliver insights and recommendations to the partner organizations. So with UNICEF Somalia, what we're doing is we're getting data on beliefs, knowledge and practices of the Somali population, mostly around health practices, health behaviors, education, differences in gender, for example, how they approach the importance of education for girls and boys. And this data that we gather from citizens can be triangulated with other sources. So even though Somalia is not easily accessed for research, there's a lot of work that has been done, especially by local NGOs, a lot of field work, focus group discussions, population surveys, household surveys. So we can triangulate our findings with those data sources. And in this approach, we're trying to gain evidence that this approach, this kind of remote research can work as a sort of a monitoring tool in a space such as Somalia that is quite fragile and insecure and costly and difficult to access for research. One of our topics that we published a report on recently was around the acceptance of people living with HIV/AIDS across Somalia. So, needless to say, it is quite a controversial topic. So, it was a very interesting case study to see if there is any meaningful engagement and discussion that can be stirred around this topic. So, how we approach this. So first of all, the first point of engagement was that we tried to generate a discussion on radio through interactive radio shows. We had a local media partner in Somalia, which produced the content for the radio shows, inviting experts to talk about the topic. And this show was aired on 26 radio stations all across Somalia, so in Somaliland, Puntland, and South Central. So when these shows, the show on HIV/AIDS aired, we invited listeners to contribute their opinion via SMS. So the SMS messages were gathered through an online platform, notably RapidPro, which was developed by UNICEF, and it's open source. And after someone contributed their opinions and sent in an SMS, so the presenter in the radio show just says, if you want to answer, well, we'd like to participate, just send a message to this and this short code. And after we received an SMS, we follow up with additional survey questions sent from RapidPro, such as demographic information, gender, age, district in Somalia, whether someone has children, and asking about additional information on the main topic. In this case, it was whether the person or their wife would ask for HIV testing during an antenatal care checkup. And the participation was quite good. We received, the show aired for 1 week, and we received around 8,600 messages from almost 7,000 participants. And the messages were quite messy and noisy, so overall we had almost 4,000 messages which were suitable for analysis. So this is part of the results, like the end after all the analysis. This is the end point where we got. I'm not sure the labels are visible. So again, the question was whether participants think that people living with HIV/AIDS are accepted in their community, and why. And here are the most common responses. The counts, if you can see, are pretty low. It's around like, you can't see. Okay, so I'm just gonna narrate. So like the counts for the first bar go up to like 300. It's so low because these are the messages that were manually labeled. So these do not include automatic labeling, which I get to later. These are just the messages which research assistants labeled manually. And the beliefs, which were like the reasons for lack of acceptance of people living with HIV/AIDS, were things like HIV/AIDS can spread very easily, so we don't want them in our community, or that they say it's a very dangerous disease, or they say that people need special care, so they cannot be part of the community's daily life. Yeah, I'm sorry, just jumping around. And conversely, the most common reasons for accepting people living with HIV/AIDS is when people thought that HIV/AIDS cannot be transmitted easily, or they say that people living with this disease need extra support. So the challenge here is getting from the messy, unstructured SMS messages to structured data which can be explored visually and analyzed. So we're trying to make sense of this massively unstructured text in local language. Like this is the case across all projects. We're working in local language, analyzing local language data, which most often than not is a low resource language. So for Somali, there are very few computational resources or computational linguistic resources available. There is a few, but they are quite hard to access. They were developed for specific projects and specific use cases, and it's absolutely not trivial to adapt them for purposes, for parsing the language. And another issue is time. So if we would like to deploy something relatively quickly, we cannot spend a year or two trying to figure out and build a language model from scratch. So these are the challenges we need to somehow overcome. And this is a general overview of the workflow and the process we're using, starting from the messages, the message corpus, and ending with with analysis and insights. So after we receive the message corpus, we do some pretty basic text processing, removing punctuation. And well, removing punctuation was a controversial issue because we were losing smileys. So this led to a pretty heated debate within the organization. But then we decided that we just at this point cannot pay more, cannot dedicate more resources to that. And after we moved to message exploration. This is an entirely manual process. It involves human knowledge and expertise going through iteratively a sample of messages. Then we use thematic analysis to find out and extract broad themes, the main lines of thought that appear in the messages. After that, we need to structure that into labels and do manual labeling. So research assistants go through a set of messages and label whether it displays a certain idea or not. Like this message says that HIV/AIDS can be transmitted easily, for example. And from then on, we move to the visual exploration and analysis part. So as you've seen, like on the top right, we're using manual labeling and automatic labeling. So in practice, this means machine learning, text classification. So the cycle is we label manually a set of data, which will become the training data. We use a classifier and evaluate the results by code. I'd like to point out here the immense human knowledge and expertise that is required in the whole process throughout, going through the messages, finding emerging themes, then consolidating those themes into quite well-defined labels, which can then be used as categories. And throughout, ensure that all the research assistants working on the data share like a solid understanding of the labels. They understand the same thing. And then we identify labels which maybe have low message counts. Like we have to decide whether we keep it and go with qualitative analysis or try to collapse it and modify the whole coding frame. So it's quite a slow and iterative process, but it's very, very important. So, and the challenges of the machine learning part. Of course, SMS data is short, because it's of short messages, it's pretty messy because it's just open-ended questions, so people really can say anything, and in many cases, even in one or two short message, they can convey like very complex ideas which lead to complex themes and labels. And also we receive a high amount of irrelevant messages which are either noise or just simply not related to the question and replying to like something completely different. I think once someone complained that they even sent a poem last time and we didn't respond. So for the technicalities of the machine learning, we use a binary classifier with a logistic regression for each code. So we have a classifier for each code, like saying this label, this code is present in the message or not. And as features, we're using either bag of words approach, so it's just either whether a word is present in the text or not, or sequences, co-occurrences, or even sequences of characters. And we add some knowledge on the language, no complicated language model. We have a few things we can, with which we can increase the accuracy of the classifier. So we add keywords for each code and spelling variations of it, and also we have a couple of spelling rules. So we collapse some of the spellings into, well, not a standardized or true, but like to a common spelling. So we can find easily variations and treat them as the same. The code for the classifier is open source. It was and is being developed by Guy Emerson, a computational linguist consultant working with us. I encourage you to take a look at the code because it's not just interesting, but I think it's really beautiful. So I think it just reads amazingly well if you want to read beautiful Python. A bit about the results that we get. It varies significantly. There are a couple of causes to that. It depends very much how complex an idea we're trying to capture with a code. Sometimes it's just difficult even for a human to find and tell the nuances between two codes and why and how they are different. And also it very much depends on the type of language that is used. So the next challenge from here is how and why could we do this real time? So in this previous use case, we had the full corpus of messages, and we just used we did the labeling and classification after we received the whole data set. So could we use this? Could we use this real time, and could we incorporate the extracted labels in the interaction itself? So the context for this project were that we're just really testing and piloting at this point is the ongoing drought situation in Somalia, which is contributing to the spread of diseases such as acute watery diarrhea and cholera. And we're trying to cooperate with UNICEF to understand the water sanitation and hygiene situation in Somalia, especially the accessibility of clean water and the water treatment practices among other questions. And our specific focus is on the barriers. So what are the barriers that people face with accessing to clean water? So a sample interaction could look something like this. Like we ask in an SMS survey, have you treated your water recently? Like someone replies back, not at all. Why not? Well, I don't have any aqua tubs left, so I cannot really treat my water anymore. So with a real-time classifier, we could categorize this that this person has no access to chemicals. So this is the barrier to access to clean water. And we could send targeted information based on the response, such as you don't necessarily need chemicals to treat your water. You can, if you boil water at least 10 minutes before consumption, that already reduces the risk of transmission of cholera. Or as another response, someone could say, I don't treat my water because I don't want to get sick. And there's a common misconception that chlorination is unhealthy. So in this case, we can say it's actually safe to drink treated water. So you can go ahead. So what we need to do to get this point is first do a first round of data collection and labeling, train a classifier, evaluate, deploy it online. And the only thing it would do is receive a text message from the online platform, runs the classifier, and returns the extracted label. Or if we don't trust enough the prediction, we can either send a targeted message based on the label or a generic message if we weren't able to extract one reliably. So as I mentioned, this is still in the pilot phase, so we're still working on the technical details and really looking forward to the results. And there's a huge amount of open questions and challenges. For example, we need to validate in an ongoing way the categories that we're using, because they might change from the initial stage of the data collection. So we need to make sure that we update the categories and like to the types of answers people are giving. We need to be conscious of the threshold when we trust a certain prediction. We're still unsure of what effect this will have. Will it stir engagement? Are people going to get confused? What's the effect what's the effect of error? What if we're replying something that doesn't make sense for the person in the context if we miscategorize their message? And in general, how we make use of targeting to make the communication more efficient. And I'm really looking forward to see how it goes down. Thank you very much for your attention. Do you have time for questions?
My question is, have you investigated maybe using some linked data to expand on that? So it's either, so this is the language issue, that you don't have enough data that's coming in there. So if you try to add maybe news content to help with some of the text, like building up your text engine before, to add to the text that you're getting that's being able to make it more richer.
I see. No, no, we don't, because what we've found so far is text SMS messages are quite specific in format and style and in conversational style. So if that responds to your question, so we weren't using other text sources. Does it respond to your question? Not really.
I think you can add to it's not saying you're using the news article as being the base, but then helping actually enrich the short text so that you maybe give more context as you're getting the response. Not that it's replacing.
I understand. Okay. Yeah, that's an interesting point. We haven't used it, so I will try to find you after the talk and ask you about this approach. Thanks.
Yeah, thanks for the great presentation.
Thank you.
I just wanted to ask whether you use previous messages from the same user in this classification.
Sorry, could you please repeat?
Do you use previous messages from the same user sort of in the prediction? Or do you predict just on one single message?
Okay, we're collating the messages by day, because like this is kind of arbitrary. So we're using messages from one day from the same person as one entity, like as one text. But because if there's a longer response, they just send it in a few messages after each other. But then we treat messages from different days separately. So multiple messages are assigned to the same person.